Hmm. Hi, Rajesh. Rajesh, can you hear me? Hello.
Morning, Anna. I can hear you.
Okay, sorry. Rajesh,
Yeah, yeah. Hi.
just a minute. Huh? I'm just waiting for people to join. Just give me a minute. think Raj.
Hello, sir.
Hey, Raj.
Can you hear me? Yeah.
I can hear you, Raj. Thanks for joining. We are just waiting for the people, and we'll start in a couple of minutes. Okay. So, in the meanwhile, I know about Shoaib and Sai. I just want to know from Rajesh, Raj, and Ravu. Uh, at a high level, your background, if you don't mind, very high level. We can start with Rajesh. Rajesh, are you there?
Yeah, yeah. This is Rajesh. Yeah, I'm working as a PLSQL developer.
Yeah.
Uh, I have almost 15 years experience in the PLSQL development.
Okay.
I'm looking forward for the Snowflake.
Okay. Okay. Got it. Got it. Okay. Cool. Thank you so much, Rajesh. How about Raj? Raj, I can see your name as Raj DevOps.
Yeah. Hi. I am. I am from the infrastructure background, infrastructure management.
I see.
So I'm trying to. I'm here to learn. I'm trying to get into either DevOps or data engineering, whichever is good.
Mm-hmm.
Uh, so yeah.
Okay. Okay. Cool. Makes sense. Thank you so much. Kalyan. Kalyan, are you there? Kalyan Sagar?
Hey, hi, Sri.
Hey.
Hi, everyone. This is Kalyan. I have 7 years of retail banking experience,
Okay.
and later I shifted my career as ETL admin for
Okay.
Talent Tool. I
I
worked
see.
there for 2.5 2 years,
Uh-huh.
and then I came to pursue my master's now.
Oh, okay.
I want to become a data engineer. So
Okay.
that's the reason I joined this course.
Got it. It makes sense. Okay. We'll start anyway. So maybe people will be joining. So just to start with, my name is Srinivas, and I have nearly 20 plus years of IT experience, and I come up with a combination of data engineering and data science, and some part of machine learning operations, and also agentic AI as well. But all I use as part of Snowflake only, majorly, and a bit on Python. And as per the today's agenda, let us go with some discussion about Snowflake, and also like how Snowflake is different from other data like bases in the cloud, and how it is different from the traditional data warehouse, and how Snowflake will be the next generation of big data. We'll see. Let me share my screen. In the meanwhile, I request everyone to ping your numbers in the chat who are newly joined, your mobile numbers and email, so that I can share a recording after the class. Let me know you're able to see my screen. So when I talk about Snowflake, and before jumping into Snowflake, if you heard about data warehouse, so majorly this data warehouse term is not new. So whenever you see in the early 90s or before that also, there were no those many databases in the market. People were using electronic files to store the data, and as soon as people started finding difficult to manage these files which having dependency, the new databases came into the market like DBase, and some of the command line interface databases came into the market, and later DBase has been upgraded to FoxPro, which is a graphical user interface which was very popular for in the banking sector. With the base of FoxPro, we got the early stages of 90s, we got the Oracle database with some security and extra features, and which became popular after very popular after like it has been released. And with the success of Oracle, we also got other relational databases like MySQL, Sybase. We also got like SQL Server and Postgres. Many different RDBMS came into the market. But the objective of all these databases is to store the data by manipulating it from different sources, and finally use that for the application development. So where this RDBMS like Oracle or other databases, the objective is to use this database as a backend and build a front end to connect to this backend and populate the data and use for some analysis also. But the analysis was very limited that time. People were majorly focusing on only extract the data and normalize it and store in the traditional RDBMS. But this was the activity every enterprise company started doing, and they started building their own databases with the database servers, and with primary and secondary, people started hiring database administrators as well to maintain that. Up to like end of 90s, every company was successful to maintain their own databases. Many enterprise companies started using, and slowly every company started building their own databases to maintain their enterprise level data. But as soon as people started thinking on how to analyze the data, that is where the challenge started, because there was no those many tools to analyze the data, because even to want to analyze the data which is in the real-time environment is not easy, because that data will be frequently may change, and even if you start analysis today, tomorrow it may change. So real-time data is not right solution for analysis. So that is where in the end of 90s, companies started thinking for an alternative solution. The solution is nothing but separate the real-time data into another database and store only historical data, not present data, and call that as a OLAP, and which is nothing but the conventional data warehouse. The online analytical processing started in the end of 90s and it has been continued after like early 2000s. And most of the data which people leveraged for this particular conventional data warehouse to build is the RDBMS data only, majorly. And then some set of CSV files and flat files also. Like Oracle, SQL Server were very popular to build the enterprise level data warehouses, and some set of CSV files also people were using. And which tools were famous that time was Informatica was very famous. So Informatica and other ETL tools like Data Stage, and also we got like SSIS and from Microsoft SQL Server Integration Service, and many different tools came into the market. But however, the conventional data warehouse has been built, and as soon as the data warehouse is ready, then how to go and use the data? That is where the business intelligence tools also came to the market. Like for example, Crystal Reports and the business objects, MicroStrategy, and also like SQL Server reporting service. All these tools became the part of BI, and everybody started leveraging these tools to generate the dashboards and for the analysis on top of this data warehouse. The objective of creating the data warehouse also to create or generate some kind of analysis reports. And what were the sources for this? The mainly companies' internal products and the CRM applications, and also the data which is in the form of structure, that is nothing but rows and columns. So every relational database will have group of tables which will be stored in the form of rows and columns. And whoever wants to work on this particular conventional data warehouse need to know any one of the database, either Oracle or SQL Server, and one ETL tool like Informatica or other ETL tools. And even the data loading, how the data warehouse was, people used to refresh is, every company used to run a set of batch jobs. After business hours, the daily transactions used to be uploaded into the data warehouse with a incremental loading. So incremental loading means daily transactions will be accumulated to the data warehouse. Whatever the historical data available for today or yesterday, so today you are going to add the today's transactions. So a conventional data warehouse used to refresh, it used to refresh by batch processing. A group of batch jobs used to be executed. And whenever we move to the early 2010 onwards, suddenly the data revolution came into the market, and there was a sudden data growth in the market, because there was a social media revolution happened after 2010. Facebook and many other social media platforms like LinkedIn, Instagram, and then we got like WhatsApp, YouTube. Many social media companies started generating most of the unstructured, semi-structured, unstructured, and quasi-structured data. So when I say structured data, we know which is in the form of rows and columns. We do not even need to convert it into structured. By default, it will be stored in the structured form, rows and columns. Whenever you go and see the unstructured data, for example, like videos, images, documents, we cannot store them in the database because they are in the unstructured form. So to maintain this kind of unstructured data or semi-structured or quasi-structured data, the new big data tools came to the market like Hadoop, which is a combination of HDFS and MapReduce. And both HDFS and MapReduce were very popular in the early 2010 because the big data, if at all you want to maintain, we need a different set of tools. So normal traditional database were not helping. So slowly the big data frameworks got very popular, and since MapReduce was having some challenges and limitations, Spark also came into the market, and slowly people started using Spark to process the big data also. And to maintain this big data, again, to analyze, the normal traditional existing reporting tools were not sufficient. So MicroStrategy, Power BI, Tableau, ClickView, many different new BI tools also came into the market. And the sources also for building this big data warehouse is majorly the sources were the company's internal data and CRM data, plus social media also became part of the sources. The sentiment analysis people used to build, how to analyze recommendation systems, how to recommend the products to the customer. So majority of the real-time applications companies started building only after big data came to the market. Majorly, the big data warehouse has been slowly converted to big data lake. A big data lake will have both historical and then also current data, which can be used for real-time system to build real-time systems also. So it can also manage not only structured, a big data lake can manage structured, semi-structured, and unstructured data also. And require knowledge to maintain this big data lake or big data warehouse was Java that time. People who knows Java, they used to easily, people used to like migrate as a big data engineers, and they used to maintain these big data systems also. But when MapReduce slowly got some limitations, Spark came into the market with the Scala support and later Python. So PySpark is very popular now. PySpark with HDFS is the very hard combination. And data loading frequency also was earlier only batch. Now after big data lake came into the market, we got batch and live systems. For example, credit card fraud transaction detection, or money laundering detection, or recommendation engines. If at all I want to build these kind of systems, I definitely need the real-time data. I cannot go and say a credit card transaction as fraudulent after 1 week, or I can't go and say a money laundering transaction as fraudulent after 1 week. I can't wait. So the customer will not wait. So the real-time data processing is very, very important. So the conventional data warehouse has been converted to big data warehouse and then to big data lake after 2010. But even after you building the big data environments, there are so many challenges in the big data side also. The traditional data warehouse challenges have been every company they overcome by using the big data. But however, the challenges whatever we got with the traditional data warehouse, they got resolved with big data. But how to maintain this big data, or how to convert the existing big data engineers or data warehousing engineers to upgrade them to big data engineers, that is what the biggest challenge, because the learning curve is very big, very high. So if at all you want to become a big data engineer in early 2011, 12 and 13, people should know all these frameworks, whatever you see. If I ask a data warehouse engineer to learn this and become a big data engineer, nobody used to be ready. Whoever will be passionate to learn, they used to learn. But if I forcibly ask them, they will wish to hesitate to learn, because it is not easy to learn these many frameworks and maintain the big data environment also. Even if you see the company level also, the big data ecosystem is very fragile. It will keep on changing. Every month you get new release, and the maintenance is not easy, and patching and upgrading every month is very, very difficult. The big data, the dedicated team should be available, and the big data team also need to be trained on different tools to maintain this big data environment. And performance optimization also requires manual intervention, and finding a technical resource who knows this many frameworks is also not easy. And big data administrators were very popular that time, but even now, but we can't find those many big data administrators because every big data administrator requires a Linux administration foundation as well. It is not easy to find people who knows this big data cluster management, and at the same time we can't use the people who already worked on the conventional data warehouse. Plus, if you see rare resource who knows all this, they demand high salary also. So companies got so many challenges to maintain this big data environment. At the same time, the developers also got challenges to learn these technologies and work on this particular environment. So big data engineers were having huge demand. Even now there is a demand, but compared to the cloud databases and maintaining in the cloud environment, it is easy because infrastructure management is very easy. If you see the cloud services after AWS, for example, came to the market after 2006 with infrastructure services for rental, every company's life became easy because they do not need to build their own environment and buy the infrastructure. This infrastructure cost has been eliminated after this cloud services came to the market. Like AWS came first, and after that we got like GCP and then Azure, and we got so many cloud environments. Oracle has a cloud, Alibaba cloud. We also have like IBM cloud. So all these cloud services came to the market, but the top cloud providers are AWS, Azure, and GCP in the market. Other clouds are there, but they are not that much popular. So to maintain this particular enterprise level infrastructure is not easy. So companies slowly started moving to the cloud environments. So if I want to maintain a big data cluster, I do not need to go and ask my big data team. I myself can go and create a EMR big data cluster. It's very easy. If I want to create a database server, earlier people used to depend on DBA. Now I can create on my own. I can go to Amazon RDS and I can create a Oracle database server or SQL server or any kind of database server. So these cloud providers made the life easy, and also why they are popular. If you go and see example, Snowflake also is one of the cloud database only. Like how we maintain. We do not maintain anything, but Snowflake team will maintain. But however, we will go and access the environment, and the Snowflake is one of the cloud database which will be used for both building for both batch and real-time systems. So majorly, I can go and use Snowflake as software as a service. So how Snowflake is very different from other clouds is, Snowflake, if at all I want to go and learn Snowflake, if I know SQL, that is basic level of SQL is sufficient. If I want to go and learn big data and want to work on big data, I need to know many frameworks. Plus, big data supports both structured, semi-structured, unstructured. Even Snowflake also supporting now all types of data, structured, semi-structured, and unstructured also. And live data streaming in big data side, we maintain using Kafka. We also have a Kafka connector for Snowflake as well. And stability wise, if you see product stability, big data ecosystem, as I mentioned, it is very fragile. So we can't say it is stable. So it means keep on changing. But Snowflake side, it is stable because every feature is integrated together. And maintenance of the product also in big data side, the DevOps team has to take care of. But in case of Snowflake side, the Snowflake team will take care of all the patching, upgrading, and provisioning. We do not need to maintain anything. And performance optimization, if at all I have to perform, I want to go and implement, I need to do manual intervention. I need to write some scripts to optimize the memory in big data. For example, Spark, we have some functions and methods, best practices to optimally use your memory. But in case of Snowflake side, it is inbuilt, no need of any manual intervention. And also data transformations, if you see, every ETL project will have data transformations. To handle that in big data side, we use PySpark scripts commonly. But in case of Snowflake side, I don't need to write any code because we have already the GUI tools available, like DBT, we have like Matillion, StreamSets. We also got new tools such as like Fivetran and Police ETL also in the market. These tools will allow us to implement the data transformations using the graphical user interface, like Informatica, how Informatica is to provide the graphical user interface to implement the transformation logic. We can also use these particular GUI tools also to implement that. And supported size also, both big data as well as Snowflake, both will support unlimited. And resource availability, it is not easy to find a person who knows this big data because it's very hard to find. But in case of Snowflake side, it's not that much difficult because people who knows SQL, we can easily train them. It's very easy because most of the commands will follow ANSI SQL, and we can easily learn each SQL command, and we can simply manage our Snowflake environment. And coming to salaries also, it is very extremely high for both Snowflake as well as big data side. Big data anyway, it is very high. And if Snowflake side also very high because Snowflake, simply learning Snowflake is not going to help. You need to know at least Snowflake plus one cloud ETL tool like DBT or Matillion or any one ETL tool. Plus, we also need to know some part of basic cloud like AWS or Azure or GCP, and one orchestration tool like Airflow. So all these four are very extensively and commonly used tools in the market with Snowflake as a combination. And coming to like use cases wise, Snowflake can be used for both real-time systems as well as batch systems, which you can maintain. But the big data ecosystem is basically used for majorly people use that for real-time data processing. So that is what the main objective people mainly use the big data ecosystem. And coming to Snowflake, why Snowflake? Why companies are going for Snowflake? If we have so many tools in the market, Snowflake is very simple. So creating a Snowflake account will not even take 2 minutes. Very simple, serverless and plug and play. Drag and drop. To create a database, I can write a command plus I can also use the interface to create. So most of the commands we can simply use as drag and drop. The interface which Snowflake is providing will have that provision to manage the environment without even writing the code. Even the advanced features like generative AI, agentic AI, also we can use some tools which Snowflake already integrated. Snowflake is keep on adding new features every day. So you can use Snowflake for any kind of purpose, not only data engineering. You can even use for data science as well. And scalability is one of the popular feature which every company will look for. Here in Snowflake, we have an option for scaling up to any amount of data, any number of users, and any amount of workload. So there is no restriction that I can scale up to only some level. And elasticity, this is very important. Size for what you need right now. Snowflake will try to use a feature called virtual warehouses to run your SQL queries. This virtual warehouse is not like a data warehouse. A virtual warehouse is a group of clusters. A cluster is again a group of machines. So the compute will happen with the help of virtual warehouse. So when I run any SQL query, all the resources that needed for that query to execute will be provided by the virtual warehouse. So this virtual warehouse will provide the resources such as CPU, memory, temporary storage. All these will be provided by the virtual warehouse. So this virtual warehouse will have size like our t-shirt size. So the size will determine how fast your query also will execute. A bigger size will run your query very faster. It will take less time to complete. A small size warehouse, if I use, your query will run fast, very slow. So the size when you increase, it will impact your query performance also. So we can change the size of this virtual warehouse anytime. If I ask you a question, in other databases like Oracle or SQL Server, if at all I want to upgrade the storage of Oracle database server, it will not allow to stop the data. It will not allow you to until you stop the database server. You definitely need to experience a downtime. Your database server need to be stopped when you are upgrading, or when you need to stop your database server when you want to do some kind of RAM like upgrade also, the compute capacity also. But in Snowflake, we do not need to worry because I can change the warehouse size even my queries are running. So Snowflake will give that provision. And flexible cost, pay as you go. All cloud providers are giving this particular flexibility where we can go and use and pay. And diversity is one of the very unique feature which Snowflake is providing, where you can store the data in one location and access from multiple different locations also. All these 5 features are only few which are making Snowflake unique in the market. And coming to as I mentioned, the one place for all your data is nothing but single place for data, where we can go and access that. And I can scale up and I can concurrently execute so many queries by using the Snowflake environment. And near zero management, which is like Snowflake team will take care of the maintenance. And also instant and live data sharing feature is there, where I can go and share my data with your account, and you can share your data also with my account. So normally data sharing will happen with FTP or through email as attachment, and some people will place in a shared location and give the access. But all these methods will provide a physical access to the data. For example, if the data is the customer sensitive data, I cannot share physically. So we have a feature called secure data sharing, which will help us to share the data without even transferring. So the user who wants to access the data is called consumer, and the user who is providing the data access is called provider. So a provider and consumer both are related, and a consumer can access the provider data. The provider has to grant the data sharing using the secure data share feature. And also Snowflake has some unique features like time travel, zero copy cloning, fail-safe, and clustering. So there are so many unique features available which are not available in other databases also. Plus Snowflake follows a unique architecture which is like multi-cluster shared data architecture. And coming to cloud, so Snowflake is a cloud platform agnostic because without any one of these clouds, I cannot create any Snowflake account without using one of these 3 clouds. If at all I want to create a Snowflake and I want to maintain my Snowflake environment, we need to select one of the clouds, either AWS or Azure or GCP. So these 3 clouds are very important. Other clouds are there, but they are not supported by Snowflake now. We need to use one of these clouds while creating the account also. And coming to Snowflake, other features as I mentioned, security and data protection, which Snowflake is providing, where I can use single sign-on and multi-factor authentication as well. And standard ANSI SQL support is providing. And the connectivity side, I can easily connect with other Snowflake partners. Like I can connect with Python, I can connect with Spark, I can connect with Node.js. I can even access the data of Snowflake from Power BI as well and Tableau. And there are so many Snowflake partners which Snowflake is allowing to integrate the data. So the connectivity is one of the popular feature, and data sharing, which I just discussed about how to share the data with other Snowflake and non-Snowflake users. We can even share the data without even transferring. All these features are making Snowflake very, very unique in the market. And Snowflake follows a architecture called multi-cluster shared data center architecture, which will have a group of clusters to maintain the environment. And other normal traditional databases will follow shared nothing architecture. So, but Snowflake is not going to follow that. And coming to like Snowflake side, we definitely need to understand about the Snowflake architecture as well, where it will have three different layers. One is cloud services layer, second one compute layer, and third one storage layer. So these three layers are used by Snowflake to maintain the environment, and every layer will have its own responsibilities. Cloud services is responsible for infrastructure management, authentication, and metadata management, and all these features will be taken care by the topmost layer, where when you log in with your username and password, we will connect through cloud services layer only. And the query processing is one of the other layer, which is called virtual warehouse layer also. This is the layer where your queries will be executed with the help of virtual warehouses. The actual development will be happening in this layer only. And any data which you are going to store in Snowflake will be available in the database storage layer. And this database storage will be maintained according to the cloud you selected while creating the account. If I selected AWS, my data will be maintained in the S3 buckets. If I selected as Azure, my data will be maintained in the VM instances. So every cloud, whatever you selected, those particular services will be used to maintain the storage, as well as even for the compute also, Snowflake will use, if it is a AWS, it uses EC2 instances. Here compute means a machine. If I create a virtual warehouse with a 5-node cluster, this 5 node means 5 machines. These 5 machines will be maintained using EC2 instances if it is a AWS based Snowflake. If it is a Azure based Snowflake, your compute will be maintained using the Azure VM instances. So every cloud, whatever you selected, that will be used for maintaining your data. And Snowflake also have like different ways to like use this particular environment. Let us try to understand it. Let me open and show you how to create a Snowflake account, then you'll understand better. So how to get a Snowflake account is very easy. You simply need to go to Google and search for Snowflake free account. And here you see there is a Snowflake free trial. You can click on this and this will redirect to the Snowflake web page, where you can start creating a 30 days free account, and you can simply mention a email ID which you frequently use. Just mention that here. So I'm just using that. And why you are signing up, they will ask you. You just mention the personal learning and development, and click on continue. It will start asking your company name. You can mention any name, there's no restriction. And enterprise, so Snowflake provides 4 different editions. We'll discuss about them in the further classes. At high level, to understand, we have standard edition, very basic level of edition. We also have enterprise level, which is the commonly and most popular used edition, and then business critical, and finally virtual private cloud edition. So all these 4, we can select any one out of all these 4. So I am just selecting as of now enterprise level and click on this terms and conditions, and I'll select AWS as my cloud. We can select either Azure. So according to your cloud selection, your data will be maintained. So as of now, I selected AWS and then simply clicking on get started. So skip that, and it is, your account is created very, very fast. So just go and check the email. You would have received one activation email also. If you go back here to the Gmail which you mentioned to create your account, you will see a activation email might have got. See, this is the activation email. So you will see this kind of email, and you will receive a URL to access your account. Either you can click this one or this one. So both will redirect to the Snowflake environment landing page. Here you need to give your username and password. For the first time, you can give whatever username which you can easily remember, and give the password according to the Snowflake password rules. Just a minute. So here we'll give. So once after you give all this detail, click on get started. That's it. Your Snowflake account is ready now. So your Snowflake account is ready, and you can start using this account for your development purpose. So this account will be available up to 30 days, and you need to leverage this 30 days account, and Snowflake also will provide a $400 free credit also, which you can see here. So your account will be need to be upgraded. Either $400 credit is completed or the 30 days trial is completed. In both the cases, you have to upgrade. Even if you finish $400 within 5 days, you need to upgrade. Or you waited up to 30 days, and after 30 days, even if you have any credits left, Snowflake will ask you to upgrade. You don't wait. You can't say that I have 3 credits left. Snowflake will only wait up to 30 days. 31st day, your account will be blocked. And you need to upgrade by adding your debit card, credit card details. And you can, once you upgrade your account, you can start using it. So always try to leverage a free account. You can ask me, what happens if my 30 days is completed? Then how can I go and use it? You can get a new account again with the same email. Snowflake will never restrict user to create a new account even with the same email, because the URL which you will access will be generated every time with a unique number. So you can create any number of accounts with the same email also. So as of now, I'm using the same email since almost 2.5 years. Same email. I create hundreds of accounts. There is no restriction that Snowflake will control you to create a multiple accounts on the same email. We can create any number of accounts. So here, this is called Snowsight web interface. Here you see multiple tabs here, but these tabs are keep on changing since 2 or 3 months, because Snowflake is extensively upgrading their environment. So these tabs, whatever you see, may change tomorrow. So you should not complain that I saw some tab here that is not there tomorrow, because Snowflake will be keep on upgrading this interface with new features. So projects will have all these features which you can use for the development. And data ingestion, we can upload the data directly from the file, or we can also upload from the cloud storage also. And coming to like transformation, here we can use dbt also, which is integrated now, dbt projects. And AML, this is for machine learning and generative AI features which we can use. And monitoring is basically will allow us to monitor the environment, because any cloud environment need to be proactively monitored, or else you will end up with high billing. So we need to monitor the queries that are running. We need to stop them if they are not getting completed. If you don't stop them, you need to pay more. You pay the bill more. And marketplace is another tab which contains the ready-made data will be available to leverage. And catalog will contain database explorer to maintain a Snowflake databases. And we also have data sharing, which I was talking about, how to share the data with other users. We can use private sharing. And apart from that, you also can see data governance and security feature also to maintain the data governance with the users and roles and other features. And compute is nothing but how to maintain your virtual warehouses to to maintain the data. And finally, admin, the tab which is available for only account admins, where they can do most of these activities. So okay, so all these tabs, whatever you see, every tab will have its own purpose. So how can we start? We can simply click on plus button and it will show you different tools here. I can create a SQL worksheet or Python worksheet or a Jupyter notebook or a Streamlit app or a GitHub repository, or I can get a dashboard, I can get a table, or I can get a stage or a view. So we have many different database updates available in Snowflake. So as of now, I just want to start with a SQL worksheet, and which will open a SQL worksheet here. So we'll try to create a database. So how to create a database? We need to run create database ingest data. So when I run this, it will try to create a database now. As of now, it just got created. And if we observe here, we can't see any database with the name ingest data now. So let me try to, I missed out ingest data. Let me try to run this. If you refresh, the old and new database will be there. So this database in ingest data is not there, but however, this is the database which I created and I am pointing to a public schema. So my database is created, I'm pointing to that. Now whatever a databases tables I create will be created under ingest data, this public schema. As of now, there are no tables. We create a table now. EMP integer, ename as string, and then salary as float. So this will create a new table. If I refresh, I will see one table here. This is simply creating a basic table, but actually the data loading will happen through some features. But just for our understanding, I'm just trying to create a base table. And once after you created, you can follow the same ANSI SQL only. Inserting the data is very easy. Insert into EMP values 10 comma John comma 30,000. So this is going to insert one record into this particular EMP table. To see the data, I'll say select star from EMP. So this is normal SQL commands only. So we can insert, we can delete the rows, we can update. So we can do anything. But to maintain this environment, we will have only 30 days. After 30 days again, I need to either upgrade the account or I can create a new account also. So we can use all the ANSI SQL commands like DDL commands, DML commands, TCL and DCL. All the commands are applicable here. All the commands are applicable, and we can maintain the data also by logging into this environment with different features which Snowflake is providing. So to creating a database is very easy here. I can create either through this create database command, or I can even go to the catalog here. Into projects. So there is a catalog, click on Database Explorer, and here I can simply click on this button and I can also create. So DemoDB is a database. I simply click on create and you will see the DemoDB here. There are two different default schemas which will be created in every new database, which is information schema and public. So Snowflake will create them for every database. Even if you see, even here also you can see those two. Every new database you will see that. The information schema is to maintain the metadata of the database, and the public is the default schema for maintaining the objects. So public will have the actual table, which you can see. As of now, DemoDB is a new database, so we don't have any tables. We can even create a table from a file also. So I can create a table by using create table statement, or I can even create from a file. How to create from a file? Click on from file and upload any file. Maybe I can upload either CSV or JSON or a different file format Snowflake is allowing. So I'll just try to use one file. So what I'll do, I'll go here. Have some data here. I'll just try to use this data CSV file, and I'll give like if this has Wolf data, and I'll just give next here, and it will try to select. These are all the columns and corresponding data types which this interface has been got identified. So we can simply click on load button. It will load all the data whatever available. So 28 rows have been loaded. If I query the data, I can see out of 28 rows, I can select the top 10 rows also by leveraging this limit 10. So select start from demodb.public.golf data. This table got created now with the file content, whatever we uploaded. So when I run this, you will see the top 10 rows. Can you see that, everyone? How easy it is to load the data from interface? But there is a limitation for interface. I can't go and upload any file or a group of files. The total size is should not be greater than 250 MB. Even if you go and see here, while creating a table from the file, it will clearly show 250 MB only, the maximum one. So DemoDB public schema. So this is the table which got created. If I run this again, we observe here, this clearly showing that 250 MB is the maximum, not more than 250 MB. If my file size is more than 250 MB, I cannot use this method. I need to go with the Snowflake traditional methods. So I just want to explain about all this as a foundation today, and I want to show you how to create a free account as well. This free account, whatever you see, this is a Snowflake 30-day free account. There is one more option to create a 4 months free account also, that I will cover in the upcoming classes, maybe tomorrow. But for today, this is what I want to cover on what is Snowflake and how it is different from other clouds, and what are the different unique features Snowflake is offering, and how to create a free Snowflake account of 30 days, and how to log in into interface, and what are the different tabs, and how to create a basic table and load the data with SQL commands, plus how to create a table by using the interface also. So this is what I want to cover. I'll just stop here. Any specific questions, if you have, you can ask now. Anyone? Any questions?
So, Sri, what is the SQL level you are expecting for this course from us?
Very basic fundamental level, but I'll cover that as part of the course. Okay.
Okay.
Whatever required, because normal SQL is different, Snowflake modern SQL is different. Because Snowflake SQL functions are very advanced functions. If I say there is a function called AISQL, and artificial intelligence SQL also is there.
Okay.
Which will just collect an MP3 file and will extract some information on the MP3 file also, for example.
Oh, okay.
So the very advanced SQL functions are there. So if at all you want to explore Snowflake, you have so many features are there, but I will try to cover which are very unique features which people use in a project, that to real-time project, and we'll try to learn only those features, and if any additional things required, I'll keep on sharing with the teams and with the different channels with the community, and also daily I'll try to share some new feature. If I find, I'll try to share that. So everything will be on track, and you will learn very new features. And with Snowflake, as Snowflake is emerging, you can see like how it is emerging with not only in data engineering side, it is emerging mainly in the agentic AI and generative AI side also. So I usually never covered any basic ML activities and generative AI also, but from this batch I want to cover that as well as a final touch.
Okay. So this course is for 40 days, right?
Correct. 42, I can say 40 to 45, because it may go, because I want to cover some part of generative AI and some projects as well. So I want to cover that as well. So we can consider it as 45 days.
Okay. Daily for 1 hour, right?
Correct. Kalyan.
Oh, okay, Steve. Okay.
6 p.m. to 7 p.m.
Okay.
Yeah. Any other questions from anyone? Rajesh, Raj, Ravan.
No, Sri, I'm good.
Okay. And I request everyone who are Muhammad. Just 1 minute. Let me see. Muhammad, I am planning to cover 5 to 6 projects, like native Snowflake plus also Snowflake with dbt and Airflow combination. And also I want to cover some part of dashboard integration as well. And some basic projects on ML side also. I'll try to show you like what projects also I'm going to cover. One project I want to cover on the like generative AI with how to go and manipulate the audio files. There is one use case. I'll try to show you that also and explain about. Yes, this is from the scratch projects only. And AWS services side, I'll cover majorly on S3 and also some part of Glue, AWS Glue, and IAM service majorly. No problem, Mohammed. And I request every one who joined newly, please try to share your numbers in the chat. I will try to share this recording and the PPT as well. So please try to ping your numbers in the chat, if possible your Gmail also. If you are part of the WhatsApp group, or you can ping in the group also. And please mention your Gmail for the recording access, everyone. Shravan, any questions from you, Shravan?
Like you will be covering Matillion and everything, right?
Matillion I may not cover, but I cover DBT.
DBT. Okay.
Because this particular course I am just planning with DBT, and I try to see if possible, if time permits, I'll try to see other ETL tools are there like Fivetran. I'll try to cover that with DBT. Okay. Yeah. Okay, that's all for today. I will continue tomorrow, and we'll try to see some part of the architecture in detail, and also we'll see some basic commands on Snowflake and the modern Snowflake SQL commands, not only basic SQL commands. And I'll try to show you some functions which are basically very intelligent functions which Snowflake is providing, and we'll try to see them. Okay. Thank you so much, everyone.
Thank you, sir.
Yeah, thank you.
Thank you.
Thank you.
Thank you, sir.
Yeah, no problem, Mohammed. Hello. Hey, Dia, how are you doing? Yeah, you people forget me, right? You people forgot me, right? No? Hmm. Hmm. Uh-huh. Okay. Uh, it's not so. Hmm, I got it. I got it. No, weekday batch or weekend? Weekday. That's what I'm asking. I have currently 7 to 8:30 मेरा ये लीना का चलता है. Lena, maybe I'm just thinking most of the course we completed some part, and maybe this month end I'm planning, but we cover by this month end. But how about like the candidates background? Are they local, or are they out of India? Okay, 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 okay. We can do in the morning 6 to 7 then. Evening I तो मेरा ये, so morning 6 to 7 only as of now. हाँ, डेमो तो कर सकते हैं, डेमो तो कर सकते हैं. 8:30 9 को कर दो आप. 9 PM को, क्योंकि 7 to 8:30 लीना का चलता है ना, इसके बाद करते हैं. I have that. I'll share you. Maybe that is you need to go and prepare from your side. I'll share you. So you need to do some kind of manipulation. How you go and add all the that you do ना. हाँ, फॉर्मेट no टेम्पलेट में करना आपको. ओके. श्योर श्योर. या या या. थैंक यू. थैंक यू. या. श्योर श्योर.